at the university, and we'd like you to come over. It's kind of more explaining to the high school teachers how engineering gets applied in the real world once you go past high school and college into business applications. So that's really our role, and I think, I guess on a personal level, I graduated from Weimar back in the 80s, late 80s, and we have 7 employees working for Navmar now that went to Weimar University in different capacities. So it's a nice success story. We're located just down the street here in Chester, Pennsylvania. We also have offices throughout the country. But it just goes to really Weimer's credit and Navmar's credit that we try to bring the people in who live and work in the community and around University Technology Park. So without further ado, I'm just going to go through a brief overview and then hand it over to Carl. So a little bit about our company. We started in 1977 in Warminster. We're located, as I said, throughout the country. We had a huge growth in the last 2 years directly related to this gray UAV, which we call the Tiger Shark, where we have developed the technology and the research through our engineering program, our engineering departments, and ramped up from 200 and some employees to about 500 today. So we had a huge growth based on the engineering research that we did. We're ISO 9001 certified, which means we're certified for the provisions in engineering services, which in layman's terms means we follow a lot of procedures and follow a lot of technical programs that give us some credibility with the government. Where we're located, you can see on the map, we're kind of throughout the country, primarily located near U.S. military bases. San Diego, big Navy presence out there. They're one of our big customers. The customers in Maryland, also a big naval center. And close to home, out in Johnstown, Pennsylvania, is where we manufacture these UAVs. This is just a brief overview of some of the engineering services that we provide. We have a pretty strong presence in the acoustic development sensor technology arena in the engineering world, where we actually go down and develop what's called sonic buoys that the Navy uses to detect both friendly and unfriendly boats out in the open ocean. Carl's group is that green section, which is the UAV engineering aspect. We went from an engineering aspect company to a production company, and now production and training and deployment. So we basically have the whole engineering package rolled into one nice business plan for the network. These are some of our key customers. Primarily, it's the DoD, which is the Department of Defense. As you can see, we have the United States Navy, U.S. Marine Corps, and some of our commercial customers are Lockheed Martin, BAE Systems, and Northrop Grumman. So that's just really a brief business overview with the engineering aspect kind of folded under. I'm going to introduce you to Carl Engelbert. Carl is our Senior Executive Vice President in our Northeast sector that's responsible for engineering, designing, and building these UAVs. Carl?
Good morning. Good morning. So, let me make sure I know who we are. We're science and math technical teachers in high schools. Correct. So I'm looking at people that are raising the future of this country, and I hear about STEM, and because I'm an engineer and I've been in the technical disciplines my life, and I go to conferences and I look out over the audience, and they're mostly white-haired people. I don't see the young people there, so I think we're all starting to get it. The work you do is a really important work for the future of this country, so I'm glad to be here. I was in the Navy for 22 years, and saw a lot of things there, but also as I rose in the ranks, I wound up giving more and more briefs. Of course, the worst brief was the one right before lunch, where you're the speaker between people and their food. So it won't bother me if someone wants to get up and grab a soda or something, if it's okay. I don't really use it. But it will not bother me if someone wants to stand up and stretch or do something. The other thing I learned in the Navy is the worst thing that can happen is you have to give someone else a brief because they get called away last minute. And Bill Sackett, who is a one-year grad, an engineer, the lead production engineer for our unmanned airplanes, got called away to a conference. He found out about this morning, 11 o'clock conference call. This is kind of interesting, but it's sort of why I like what we do. It's you never know what you're going to be doing in the day. We got selected to do the autopilot integration on a new airplane, completely new design, long tapered wings for high altitude, long endurance flight, and so they want to fly this thing in 60 days. So from concept, it's been developed for a while, but we started cutting up in 60 days from now they want to fly. So it takes a lot of people meeting, considering everything, making sure that we're ready to go. And so they had a program review meeting. He's on a conference call with people from Florida and Oklahoma and Georgia and so on. I'll do what I can with his slides. I don't mind answering questions as we go or at the end, whatever. Okay, so UAS, Unmanned Air Systems. This is a company called the drone these days. We usually call UAVs an unmanned air vehicle, and an unmanned air system is the airborne vehicle and a ground control station. Because even though it has an autopilot that you can program it for automatic takeoff, automatic landing, waypoints, altitudes, all that. Still, there's a man in the loop, both to control the airplane if need be, and also the airplanes we build are used for surveillance. So they have sensors on them, either a camera system or electronic signals intelligence gathering or a radar of some kind. So UAS is unmanned air systems. At this rate, you're never going to have lunch. Okay, so we are an engineering firm, but there's a lot, there's a lot more to putting a product out in the field than just building it. So we do the design, we now manufacture. There's training involved, and so we help with that. RD&E, research, development, testing, evaluation. So a lot of what engineers do is, I guess that's one of the things about engineering and technical disciplines is you can, if you're in research, you could be in the university doing very basic research, or you could be doing development where you take research other people have done and you integrate it into a new system, a new application. Test and evaluation. I had a chance in the Navy to do some test and evaluation, and it's very interesting where when a new system gets developed, long before you give it to the end user, you have to rigorously, bring it out. And so that's a discipline in and of itself. And some people gravitate towards the research. Some people like to be out on the flight line, just taking data, making the thing fly, getting the tests, getting the results, getting them distilled and so on. Deployments. So we set these things flying overseas in Afghanistan, formerly in Iraq, and so we send people over there. We have several hundred Navmar employees are in Afghanistan now. Like I said, we used to be just an R&D, research and development company. Now we got into this because there was a need. So not operators, and then product support, anything that's out there in the field. When your iPhone comes out, you can take it down to the Apple store. There's 50 blue shirts in there, and they fix your product, right? So you put something out, and you have to support it. So we do that. And I think that's just about how we got to just the kind of history of it. So what you're looking at here is the Mako. And it's Mako is a type of shark, a small shark. And so it was developed very quickly, and it got overseas with cameras, carries up to 25-pound payload. It got over to Iraq to provide surveillance and it was available to the local commanders so that they could, if they were going to send some people outside the fence, they could clear the route themselves with a sensor to see what was out there. They quickly realized that it needed more endurance and needed to carry heavier payloads. So we scaled it up to the Tiger Shark, which you see in the lower. That's what's flying there now. On the picture on the left, you see is a launcher. So right now it requires a runway to take off and to land. And so that limits the places where you can deploy this. With the launcher, which we designed and had built, a pretty simple device. Just have an accumulator here, take a Honda generator to run a pump it full of air, and then release it all at once to go out to shoot and fire the airplane up. So, interesting design engineering project, just out of the blue, but really fascinating for the people who got to build it and test it. So that enables you to take off without a runway. And then we have developed a system where you can recover with a parachute. When you're ready to land, just kill the engine and deploy a parachute and land it. So that's the way to eliminate this need for a runway using engineering design and development principles. So this is just some of the work we do building the airplane. You can see it's, as the Wright brothers we're not that far ahead of them in terms of laying up wing grips and structures. So the design was done with design engineers, but then we have manufacturing engineers who have to make sure that it's producible at a low cost, and always looking for more cost, and always looking to reduce variability in each copy, so that it's going to be reliable. So this facility is out in Johnstown. Up in the upper right, you see a numerically controlled cutting machine, and as manufacturing gets more and more automated, the more and more robotics we get, then whereas before you needed somebody with